In this lesson, you will learn how to find the combinations of a set of elements. So we need to define our terms. What does combination mean? Well, a combination is simply a collection of things in which the order does not matter. So the key word here is collection. That is different than permutation, because permutation is an arrangement in which the order does matter. So an example of this would be Levi, Marvin, Nellie, and Olivia are trying to make a group of 2. And the question is, how many unique groups can be made? So with a group of people, it doesn't matter the order in which I pick the group. So the possibilities that I have could be Levi and Marvin, Levi and Olivia, Marvin, Olivia, Levi, Nellie, Marvin, Nellie, or Nellie and Olivia. So we have 6 options. But it doesn't matter if I pick Levi and then Marvin, or Marvin and then Levi. The order does not make a difference. So yes, we could list all of the possibilities out like we just did. But the objective is to get to the point where I don't need to list them out, but I can use mathematics to get my solution. So here what I do is I think, okay, I have 2 people I'm choosing. 1, 2. And for the first person, I have 4 people to choose from. Levi, Marvin, Nellie, or Olivia. So I have 4 people I can choose first. And then, with that same person, I now have 3 options to pair up with that person. So what I have is 4 times 3, or 12 possibilities. But now we have to take into account the fact that the order does not matter. Meaning I could pick Marvin and Levi, or Levi and Marvin. It does not matter the order. So I divide out the repeats. And if we're picking 2 people at a time, the ways that we can arrange those 2 people would be 2 factorial. So I divide by 2 factorial, or 2, which gives me 12 over 2, and my solution would be 6. Now, just like with permutation, there is a quick way to write this, and that is by using the letter C. So here the 4 means we have 4 people to choose from, and 2 means we're picking 2 people at a time. And the C means combination. So that is just like permutation. The only difference is permutation has a P, combination has a C. And we can read this in English as 4 choose 2. So yes, we can say 4 C2, but many times we would say 4 choose 2. So calculating these combinations, we could go through the process that I just showed you, or we can use factorial like we did with permutations. So notice with combinations what we have. We take the 4 factorial, and then we take 4 minus 2 factorial, and then we take another 2 factorial right here. And notice that's basically identical to permutations. Permutations, we took the 4 factorial and divide by 4 minus 2 factorial. So notice we have all of that right here. But the difference is this 2 factorial. And that is when we divide out the repeats. So we divide out the repeats because we have 2 people that we're choosing, and we have to divide out by 2 factorial to account for those repeat people. So when you calculate this, 4 factorial and then 2 factorial and 2 factorial on the bottom, you'd get 24 on the top, 4 on the bottom, which would divide to give me 6. So either way we want, we can list them all out. We can go through the other process, kind of like with permutations, or we can go through the process here with factorial. So make sure you can kind of think through all 3 of those different methods. But obviously the listing out of the people or the groups will not be the best method of solving. So in general, we can say that NCR would equal n factorial, so this number factorial, divided by, then take the r factorial, and then subtract n minus r and make that a factorial. So now looking at a very similar example, where now we have Levi, Marvin, and Nellie, but not Olivia in this case. So we have 3 people that we're choosing from, and we're still trying to make groups of 2. So yes, we could list them out to get groups with Levi and Marvin, Levi and Nellie, and then Marvin and Nellie. But our objective is to do this without having to list everything out. So we are choosing from 3 people, and we're taking 2 at a time, and we're making groups of people. So the word group would signify that we are doing combinations, and we have 3 choosing 2 at a time, so we can write this as 3C2, which means 3 choose 2, and mathematically this would be 3 factorial over 3 minus 2 factorial, and then divide out the repeats, so we have divide by the 2 factorial. So when you solve this, you have 3 factorial over 1 factorial, and this is just going to be 1, and then 2 factorial down here. So you solve this, you have 3 times 2 times 1 over 2 times 1, which would leave me with 3. Here's another example where I have 8 individuals running for 3 student body offices. And the question is, how many unique groups of individuals could I have? So once again, we see the keyword groups. So it's going to be a combination. We have 8 people. We're choosing 3 at a time. So the way to set this up would be 8C3. And then mathematically, we can write this as 8 factorial, and then divide by 8 minus 3 factorial. So that part is just like the permutations, but then divide out the repeats, so divide by 3 factorial. So I have 8 factorial over 3 factorial times 5 factorial. When you multiply everything out, the 5, 4, 3, 2, 1 would cancel with 5, 4, 3, 2, 1 here. 3 times 2 is 6, so the 6 would cancel with the 6 up there, leaving me with 8 times 7, which is going to be 56. Another question might be, in how many ways can a committee of 5 be chosen from 7 teachers and 6 students if all are equally eligible? So here we're dealing with groups. So the keyword group is not used, but a committee is a group of people. And we have 5 people, and we're choosing from a total of 7 plus 6 students to give me 13 options total. So what I have is 13. I'm choosing 5 at a time, so I can set this up as 13C5. And then to solve this, we take 13 factorial, divide by 13 minus 5 factorial, and then divide out the repeats, so I divide by 5 factorial. So this gives me 5 factorial and 8 factorial for the bottom. I can multiply this out, and we can use the calculator if we want, but we can simplify a little bit first, where 8, 7, 6, 5, 4, 3, 2, 1 would cancel on the top and the bottom. And then on the bottom, we can start canceling things as well. 5 and the 10 can cancel. I'm left with 2 over 1. And then the 4 can cancel with the 12. I'm left with a 3 over 1. And then the 3 can divide with a 3. And the 2 can divide with a 2. So what I have now is the 13 times 11 times 9 for the top. When I multiply those, I get 1,287. Here we have a similar example. We are creating a committee. So once again, keyword group, and that's going to be a combination. And we have a committee of 5 to be chosen from 7 teachers and 6 students as well. And the committee must include 2 teachers and 3 students. So what we have is actually 2 scenarios. We have the 5 is kind of irrelevant for this problem because that is built into the fact that we have 2 teachers and 3 students. And 2 plus 3 is 5, right? So then teachers, we have 7 teachers to choose from, and we're choosing 2 teachers at a time. So for the teachers, we have 7 choose 2. And for the students, we have 6 students to choose from. We're choosing 3 at a time. So that can be written as 6C3. Now because these events are not exclusive, meaning I can have both occurring at the same time, I'm going to therefore multiply those 2 answers together. Another way of thinking of this is we have 2 teachers and 3 students. So the word and would signify that we are multiplying. So then we solve 7c2 and then 6c3 and then multiply. So 7c2, we would have 7 factorial over 2 factorial, then multiply by 7 minus 2 factorial. And then for the other one, I can take the 6 factorial and then have the 3 factorial, which divides out the repeats, and then have 6 minus 3 factorial as well. So that's going to leave me with 5 factorial and a 3 factorial when I subtract 7 minus 2 and 6 minus 3. And then from here I can solve, where for the first one I have 7, 6, 5, 4, 3, 2, 1 on the top, and then 2 times 1, and then 5, 4, 3, 2, 1 on the bottom. This can cancel, 5, 4, 3, 2, 1, and the 2 can cancel with the 6 in the numerator. So I have 7 times 3, or 21 for the first number. And then the other one, I have 6, 5, 4, 3, 2, 1, and then 3, 2, 1, and another 3, 2, 1. The 3, 2, 1s can cancel. And then I have the other 3 times 2 times 1. 3 times 2 is 6, and the 6 can cancel with the 6 up on the top. So over here I have 5 times 4, or 20. So my answer is going to be 21 times 20, which equals 420. Now this next example is the most complicated one that we are going to deal with in this lesson. Here we are told that a standard deck of cards consists of 4 suits, clubs, diamonds, hearts, and spades, and each suit has 13 cards. And the question is, how many 7-card hands can be dealt that include 5 cards from the same suit and 2 cards from a different suit? While looking at the fact that we have 5 cards from the same suit, we can represent that by showing that we have 13 cards and we're choosing 5 at a time. So we have 13 choose 5 to get 5 cards from the same suit. So 13 choose 5, or 13c5. When we solve that, we have 13 factorial over 5 factorial times 13 minus 5 factorial. So we have 13 factorial over 5 factorial times 8 factorial. And you can multiply everything out. 8, 7, 6, 5, 4, 3, 2, 1 would cancel with 8, 7, 6, 5, 4, 3, 2, 1 here. And then the 5 can cancel with the 10, leaving me with a 2 and a 1. And the 2 can cancel with the 2. And then I have 4 times 3, which is 12, and that cancels with a 12 on the top. So what we have is 13 times 11 times 9. When you multiply those, you get 1,287. But there are 4 suits to take into account. So this just accounts for 1 suit, and to account for all 4, we multiply that 1,287 by 4. So 4 times 1,287 would give me 5,148. But then we are also drawing 2 cards from a different suit. So to account for that possibilities, what we do is we know that since there are 13 cards in 1 suit, if we take the total number of cards, which is 52, minus the cards from the same suit, we're left with now 39 cards from the other suits. So from the 39 remaining cards, we are choosing 2. So we write that as 39C2. When you solve this, you have 39 factorial over 2 factorial times 39 minus 2 factorial. So the 39 minus 2 factorial would give me 37 times 36 times 35 times 34, etc. And on the top we have 39 times 38 times 37 times 36, etc. And notice the 37 would cancel, 36 would cancel, everything below 37 would cancel, leaving me with a 39 and 38 on the top, and this factorial is now gone. So we have 39 times 38 over 2, which can cancel or simplify to give me 741. So we have 5,148 options of ways to get 5 cards from the same suit, and then 741 options of ways to get cards from a different suit. and we are combining those together. We want 5 cards from the same suit and 2 cards from a different suit. So because of the and, we are multiplying those two numbers to get 3,814,668. And that concludes our lesson for today. We will see you next time.